All right, so perpendicular lines. What does that mean? It means the two lines intersect at 90 degrees. And what does it mean in respect to the gradients? Is that the product of the gradients gives me -1. So let's look at this part first, because that's the main feature of perpendicular lines. So first of all, M1 is the gradient of one of the lines, and M2 is going to be perpendicular, is going to be the gradient of the other line. So if they multiply to get to -1, first of all, that means they've got to be opposite signs. If this is positive, the other gradient has to be negative, and it also has to be the reciprocal of the other one. The reciprocal, and remember what reciprocal means, is that means that it's this as a fraction inverted. So 2 as a fraction is 2, and then flip that upside down and it's 1/2. So what I call this term is, I call it opposite reciprocal is what I call it. Opposite meaning the other sign, and reciprocal mean what it multiplies to get that 1. So flip it upside down, whatever you want to say. So if I've got a gradient equal to 3/4, then the perpendicular gradient is going to be the opposite reciprocal. So it's going to be a -4/3. And I can just keep going. If I have the gradient equaling -3, then the perpendicular gradient would be the opposite sign, which is positive, and the 3 inverted, which would be 1/3. And I can keep going with examples here. -7/10 would give me +10/7, because if I multiplied these two numbers together, all of these pairs, I would get -1. So that's the first step in any of these problems. It's going to be figuring out what the perpendicular gradient would be for that second line. Okay, now let's look at how to write an equation. This is the real deal here. Let's write an equation. Write an equation perpendicular to y equals -2x plus 4 and goes through the point of -2, 3. Okay? So anytime we see the equation bit, we need a gradient and we need a point. And first let's figure out what the gradient of this line is. Well, the gradient of that line, it's written in gradient intercept form, is just -2. So therefore the perpendicular gradient is going to be the opposite reciprocal, +1/2. You don't need to put the positive sign. And this is the gradient you use when you write your equation. So your equation, I'll start with this form, y minus y1 equals mx minus x1, and I substitute this gradient into here. And what do I use for x1 and y1? Well, this point, of course. So y minus, what's y1? The 3, equals, what's my gradient? I just figured that out, 1/2. X minus x1 means minus the -2, which means +2, of course. And to get it in the same form as this one here, I expand and then add that 3 over. So y minus 3 equals 1/2x plus 1/2 times 2 is 1. And then finally I add the 3 to the other side, and I get 1/2x plus 4. Just the steps on writing the equation is, first step, find M1. Second step, find the perpendicular gradient with the opposite reciprocal thing. And then your third step is to write the equation using point gradient formula. Alright, so we'll try some examples where the equation isn't written out exactly like this and in a different form. So in this equation, obviously this equation looks different because y is not by itself, so I don't know the gradient right away. I can't just look at it and go, oh, yeah, I mean I can't do this and go, oh, the gradient's -2. I don't know what it is. So you can rearrange it or get y by itself. Or, you know, the notes from last time, where I said that if it's written in standard form, ax plus by plus c equals 0, and you can rearrange it, or just know that the gradient is the opposite of this coefficient divided by this coefficient. And that's going to help us here, where I say, okay, first step is m1, and m1 is going to be the opposite of this coefficient. There's nothing there, so it's a 1 over b. So the gradient of this line is negative 1/3, which I could have got if I rearranged it, but that's just a lot of work. Second step is find the perpendicular gradient. Opposite reciprocal means positive 3. Third step, equation time, y minus y1 equals mx minus x1, and we substitute all our values in. Here's x1, y1. Here's the gradient I used, don't forget that. And I say y minus the negative 1 is plus 1 equals 3 x minus 5. Expand, and then subtract the 1. 3x minus 15. Subtract the 1 over there. Negative 15 minus that 1 is negative 16. Okay. Alright, what about this one? Write an equation of the blue laser blowing up whatever it's blowing up. Okay, I mean my steps are the same. I want to find, first of all, I don't know what that point is. And I don't even know what the equation is of that line right there. And let's say they are perpendicular inside that explosion. And to find m1, I don't have the equation at all, so I have to use my formula for gradient given 2 points. y2 minus y1 over x2 minus x1. And that means my gradient between the two stars is negative 3 minus 2 over negative 6 minus a negative 10. And if my math is correct, I get negative 5 over 4 for the gradient of this line. And I don't care about the equation of that line because I want the equation of the blue laser. So, second step, what's the perpendicular gradient going to be? Gradient of the blue line, blue laser, opposite reciprocal, or 4/5. Finally, equation, y minus y1 equals mx minus x1. What points do I use here? Well, first of all, I use that gradient. I use that gradient there. And I use that point. That's the only point I'm given on that blue line. So it's y minus 4 equals 4/5 x minus 8. Distribute and add that 4 to the other side. Sorry, expand and add that 4 to the other side. And now I'll add that 4 to the other side. So it's going to be negative 32/5 plus 4. Okay, and when all is said and done, here's my equation of the blue laser in gradient intercept form. Okay, that's it.